Hey everyone, it's Mr. Anderson, and we are getting together right now to talk about section 5.3.2 from our CPM ebook. And in section 5.3.2, we are going to use a multiplier to solve an application style problem. We've talked about arithmetic and geometric sequences already. Arithmetic are sequences that grow through adding a constant. Geometric are sequences that grow by multiplying by a constant ratio. But today we're going to kind of focus on that multiplication growth, but we're going to talk about a real world application angle. So we're going to talk about how we can represent that in and using a geometric style sequence. And there's a great setup here in problem 5-91, and the problem's really good, and it gives us it lends itself very well to the goal that we're after. But in order to understand that, there's a little bit of a mock or fake article that is produced, and we're going to go ahead and read that article as the frame for our problem. And it says, "Pi phones sweeping the nation. Millions demand one. Teenagers and Hollywood celebrities flocked to an exclusive shop in Beverly Hills, California yesterday, clamoring for the new Pi phone. The store expects to start by selling 100 and expects to sell an average of 15% more each week after that. I plan to stand in line all night," said Nellie Hillman. As soon as I own one, I'll be cooler than everyone else. Across the globe, millions of fans," and the article's cut off, right? Okay, so it's talking about an initial amount and then a growth factor or a multiplier. And I've taken these things into our notes, and I'm going to go ahead here and I'm going to just kind of read the problem, and then I'm going to point out some of my thinking that I've already kind of pre-populated into some of our notes. So it says in 5-91, "Thanks to the millions of teens around the world seeking to be just like their math teachers, industry analysts predicts that the sales of the new Pi phone will skyrocket. The article provides a model for how many Pi phones the store expects to sell. They start by selling 100 Pi phone pre-orders in week 0, predict the number sold in the 4th week." Now, I went ahead and did a little groundwork here. I said if they're going to sell 15% more, not just 15% of, but 15% more, we're going to need to take the 100%, we're going to need to add 15% to that. And I know that seems arithmetic, but together, 115% means 115%. So there is our multiplier, our growth factor. And that means we're going to multiply by 1.15. All right? And in case you're not totally clear where I got that, 15% and its equivalent decimal, 0.15, those are going to be interchangeable here. The reason we want the decimal version, 1.15, is because we don't multiply with percentages, right? Okay, and here's my table. I set this table up ahead of time. They told me that in week 0, when n is 0, the number of phone pre-orders was 100. And if I'm going to go ahead and multiply by 1.15, I've got to have my calculator out. So I start with 100, I multiply by 1.15, and it tells me, oh, hey, 115 were sold in in week 1, right? Pre-orders were 100, 115 sold in week 1. All right, let's keep going. I'm going to multiply by 1.15 again. So I'll take that 115, I multiply by 1.15, and in this particular case, it tells me 132.25. Now I know I can't sell 132.25, so I'm just going to kind of round that down to 132. But then I'm going to continue. I'm going to keep going in week 4. 132.25 times 0.15, times 1.15, my fault. I got to re-enter that. And I get 152.0875, and that to me says 152. And then finally I'm going to do the last week, and just one more time, times 1.15. I hit enter, and I get 174.900625. So I'll round that up to 170. Whoops. 175. Okay, so there we go. My prediction using that multiplication rule is going to be approximately 179 Pi phones, right? And then if you were to write the number of Pi phones the store received each week as a sequence, would your sequence be arithmetic or geometric or something else? Justify. And I said because we're multiplying here, this is going to be geometric, okay? Moving on to part C here, the store is asking us how many phones we might need to consider ordering at the end of the year, and that's 52 weeks. And they say, in order to do it kind of the way we were doing our table, we would just take the number of phones we ordered in week 51 and multiply by that 1.15. The problem there, and this is the recursive equation that I've highlighted here, in order to get week 52, I need to know week 51. And in order to get week 51, I need to know week 50. Now, this isn't too tough to write. The recursive rule is very, very effective when dealing with a nice small number of weeks, in this case week 0 to week 4. It was very, very easy to make that table. I start with a starting value, in this case the number of phones for pre-order, week 0. I know that that's 100, and then I tell everyone exactly what I've got going on. In this case, to get the next term, the n plus 1 term, I take the term that comes right before that, which is the nth term, t of n, and I multiply that by that 1.15, that growth factor, that multiplier. But the issue is I'm going to have to do a lot of work on my calculator to go out 52 weeks. So the recursive rule in this case is super duper clunky. I don't want to mess around with that. Hence part D, where we get to write the explicit equation. Now the explicit equation is going to do exactly what I did to fill that table in. It's going to repeatedly multiply, and the explicit equation is actually not too bad. Let me kind of show you a little bit of a pattern here using this explicit equation, right? To get the 0th term, I just kind of took what they gave me. I said, all right, I'm going to start with 100. But then to get the first term, I took 100 and I multiplied by 1.15. Well, to get the second term, I took 100 and I multiplied by 1.15 to get the first term, but then I multiplied by 1.15 again to get the second term. Okay, one more time. To get the third term, I took where I started, multiplied by 1.15 to get the first term, multiplied by 1.15 again to get the second term, and then I took the second term and multiplied that by 1.15 again to get the third term. Do you see what's happening here? Can you recognize this pattern? I'm repeatedly multiplying by that 1.15, and it's therein we find our explicit rule. And the explicit rule for this model, or for this equation, is going to be t of n can be found using the starting value, 100, and then the term number matches the number of times I need to multiply by that growth factor. So multiplied by 1.15 to the, because I want the nth term, nth power. And this is going to work out pretty gosh darn nice and pretty clean for our rule. Now, check out how easy we can do part E then. Part E says, all right, now go ahead and find how many Pi phones the store predicts it's going to sell in the 52nd week. Well, gosh, no big deal anymore now that I got that explicit rule. T of 52, the 52nd term, 100 times 1.15 to the 52nd power. I don't have to use a spreadsheet here because I got my explicit rule. And I'm going to grab my graphing calculator, 1.15 to the 52nd power, and holy cow, that's a pretty big number. Looks like sales are going to go pretty well. I have 143,313.6966. I'm going to call that about 143,313 Pi phones. Okay? And that's a pretty nice way to be able to do that, right? As we continue, let's kind of change our model a little bit. A new Pyroid arrival to the PiPhone is about to be introduced. It's cheaper than the PiPhone, so they're more expected to sell. Okay, the manufacturer plans to make and sell 10,000 pre-orders in week 0 and expects sales to increase by 7% each week. It says, write an explicit and a recursive equation for the number of Pyroids sold in the nth week. Explicit, recursive. I think the recursive one really kind of highlights exactly what we want to go ahead and do. So I'm going to start there. I'm going to start with t of 0, and the starting value for us is 10,000 PiPhones. They start with 10,000, but then, ladies and gents, we've got to come up with what we're doing to get the next term. Well, the recursive part actually is not too bad. To get the next term, to get the nth plus 1 term, the term after the nth, we're going to go ahead and we're going to take the nth, so t of n, and we're going to multiply by that growth factor. Now, here's where we got to consider this. They said 7% more. So I'll start with 100%, I'll add 7%, I get 107%, convert to decimal times 1.07. And again, that'll help me find the next week really, really quickly. But if I want to go out for a full year, that's when I want the explicit rule. Now, let's be smart about where we came from. Our explicit rule right here was almost identical, but it had a different starting term and it had a different growth factor. Let's transfer that. Okay, the exact same model is appropriate. T of n, we're multiplying by the exact same time. We're multiplying again. It's a geometric model. It's going to be fit that exponential form, right? T of n equals the starting value, 10,000, multiplied by that growth factor, 1.07, to the nth power. I'll put a little squiggle in there to separate the explicit and the recursive rule. Then it says, what if expected weekly sales were 17% instead of 7%? Well, ladies and gents, how would that change? What would that new explicit equation be? How would it change the recursive rule? Well, the explicit rule would change oh so slightly. Let me see if I can call this out. And I'm going to try to make it stand out here. Let's use a different color, right? That's going to be, oh, that was brutal. That's going to be my 17%. And then, how does that recursive change? Well, the start value is still the same. One more 0. But that multiplier changes. And again, I'll try to call that out using a different color so you can see that change. Oops, let me slide that up. Okay? Then finally, in problem number 93, it says, oh no, thanks to the new lower price, 10,000 Pyroids were made initially, but after that, weekly sales decreased by 3%. Find an explicit and recursive equation. Okay, here's the thing. Whenever we have this thing happening, just like before, when we were increasing, I added. When I'm decreasing, I'm subtracting. So I'm thinking of 100% minus 3% because sales are going down. That's what decrease means. That means weekly sales are only 97% of what they were. This is a decay factor because 97% is equal to 0.97. And remember what happens when we multiply by a number less than 1. Our overall value, our overall term value is going to decrease because we're multiplying by a number less than 1. Check out this explicit rule. Everything is going to remain the same except for that growth factor. Okay? That growth factor now has become a decay factor. All right, and likewise with my with my recursive rule, we start with 10,000. But then, ladies and gents, I multiply by 0.97. Okay? So we're going to see an overall reduction. All right, ladies and gents, a tiny bit of review preview. There's 4. It looks like a lot here, but there is only 4 questions. All right, give those things a shot and start asking questions. Folks, thanks for watching. Have a great day.